Today we are going to talk about OSI model, which is OSI model. If we can recall to last week, so I talked about fundamentals. So all these are the fundamental part of cybersecurity. IT generally, let me just put it like that because it will really this all these fundamentals that we are talking about will really help us in every area of IT. So that's why I we schedule this particular training for every one of us to have a basic knowledge of everything, especially for some of us that we like to sit for maybe CompTIA plus, Security plus, and other certification. So all these are very, very important. And like I said also on that very day, I said that if you want to hack any device, of course, you can't just ask what you don't know about. So in every hacking, in every cybersecurity or ethical hacking, so we have what is called information gathering. So you gather information about what you know or what you want to know. So that's why all this area of IT where this fundamental is very, very, very important. So this is the model here. This is the model that we need to understand. We need to understand this model very well because here, as you can see, all of you see this. We have physical layer. We call it layers. Okay, I think I not even define what is OSI model is all about. So as you can see from here, open system interconnection. That's just the meaning of this OSI model. Open system interconnection. So now, open system interconnection. That is a 7-layer model to understand network communication. We understand network communications. Each layer performs specific portions. Of course, we are here now talking. It's because of this thing, this OSI model. That's what we are using now. As we are talking, you are at your own home, at your house, inside your room, connected and talking right now. Of course, it's because of this what we want to learn today. This make it possible. What we want to learn today. Make everything our connectivity, chatting, everything, engagement. This particular topic make it possible today. So now I want to relate it, make it very simple to understand. So normally, if you want to do any certification exam, of course, if they want to ask you question based on this particular topic, they will ask based on this particular one, the layer step by step that I follow. That is from application layer, from this application layer to presentation layer, then session, transport, network, data link, and physical layer. So if they want to ask you in any exam, they will want you to like what is the fourth layer? That is 1, 2, 3, 4. That's how they will ask you if they want to ask you in exam. But and I want to assure you that you don't need to memorize anything here. You don't need to memorize anything. By the end of this training today, of course, we should be able to know if they ask you anywhere which layer this belongs to. Of course, you should be able to say it without even looking at anything. We don't need to memorize. So that's why I put this other section, this particular, the one at the right hand side here. That's why I put the overview here. That is the first thing in this our communication is physical layer. I will explain, then followed by data link. So now I want to relate it to like in the olden days. In the olden days, you want to send letter or everything, we send it through a courier or maybe dispatch. This time we use dispatch rider and every other stuff to do all those things. So now you want to send a letter to your friend who lives in maybe in a town, maybe UK or US. You both know how to read. Of course, you guys understand how to read, how to write. So, but there is a whole process before your letter will get to that person. That is a whole process to it. That process before your letter get to that person in IT is this what is called OSI model. That's it. That's it. So now the OSI model is just the step-by-step process. Your letter or data flow when going from you to your friend. That's just about it. Over the internet. It's just about it. Just let's just be looking at it so we can we learn one or two things before the end of the whole training. So I want us to break it down. All these things that we have here, I want us to break everything down. So now let's start with application layer here. Application layer. Let's start from this application layer. So now it's just like you writing a letter. Application layer. You write a letter Then you saying, I want to send a message to my friend. You want to send a message to your friend. You pick up a pen. You write it nicely. You put emoji, put all those things. Maybe in English or any language. You just write it very fine and very neat. You said then you package everything. That process of writing it in IT, of course, we use nowadays. We use WhatsApp. We use email or Facebook, Twitter, another platform to do that process. The one I just mentioned now is a local process that our forefather that we've been used in some years ago. Picking letter, write a sheet of paper, write a nice letter in any of your language, in any of your this thing. So, but now we use application, which is WhatsApp, email, Facebook, Twitter, and any other social media platform to send our messages. So that's application layer. Proceed to presentation layer. So presentation layer, let's just look at it in this way. It's just like you making it readable, your letter that you wrote. Make it readable that everyone, the person you are sending it to, we understand. You design it very well. You made the handwriting clean. You add emoji maybe, or you translate it to the language. You do a lot of things. Make sure your message is in a way your friend you make sure that your message is in a way that your friend will understand and be able to read it very well. That's presentation layer, which is this particular one. What you had, the aroma you added to it, all those things. Maybe you want it to be neat. You add emoji, you laugh, you do all those things. Those things are called presentation layer, which is this second layer here. Then now we move to session layer. So this session layer, of course, it's just like starting a conversation. You start a conversation. So before sending the letter, you and your friend have to agree. Of course, you have to agree. Maybe you say, "Hey, we are writing letter to you. We are writing letter now." You just in that case in IT, of course, this is like opening a communication line in IT. This means both sides are ready to talk. You and I, we are ready to talk. This conversation now, this is our training. We all of us agree that 8 p.m. we are going to meet. That's session layer. We are having the session now. We are the session at the moment now. We are the session at the moment now. So now, we started. So this is like I said this is like opening a line in IT. This means both sides are ready to talk. You and I, we are ready to talk. Then we started the conversation. We started the training. So now, in nutshell, what I'm trying to say in this session layer, this current engagement at the moment now is called session layer that we are having at the moment now. It's called session layer. So now, the next step here is transport layer. The next step here is transport layer. Okay, let me break this down. So let me break it down so we can understand this transport layer. In olden days, when you write a letter, maybe first page, your letter did not occupy, maybe you still need to write more, or maybe in your exam hall, you need some people request for extra sheets. So all those ones, that transport, I will let you understand very well. So you realize the images is so long, you break it down into pages, maybe page 1 to 3, and make sure that you arrive in the right order. I want you to listen very well to this transport layer because we have two things that we need to understand. And it's very, very important for us as a cybersecurity engineer to understand that two things very well. Yeah. So you decide. After you have written your letter, you have decided you want to send it now. You want to send the letter. So you now think, should I send it carefully? If you want, it's in two ways. You want to send it and you want to make sure that this letter get to where it's going. That one is a must. That's first thing. Second one, we just say, okay, let me just send it. If the letter maybe let's get to where it's going. If not, then anything can happen along the road. So this now take us to what is called TCP, which is transmission control protocol. So we are in transport layer. So I say here, depend on you. It's in two ways in IT. In a normal way, I'm very sorry if I'm using a Lagos State option. So because I know most of us are in a different part of the country and even in Africa, I understand very well. So, but that's where I know very well. That's why I normally use it, or just relate it to your area. So it's like you want to send something to, you are staying in mainland, you want to send something to island. So you have two options. It's either you send it through dispatch or maybe Uber or others. You want to make sure that the letter will get to that place. Or you can choose to use Agbero, all those conductor, all those yellow bus. So you are on your own. If you are sending, maybe you are sending system, or you are sending package online, and you want to use Agbero, all those yellow bus, to help you send your package to your customer, you're on your own. You can either get to the person, or it depends, you're on your own. Or maybe you want it to be, if you want to be sure that this thing will get there, it's either you use Uber or maybe all this bike, this you just use dispatch. That's all. So that's two ways. But in IT, we have two ways of doing that. The first way of doing that is called TCP, which is first one. It's called TCP. Then the second one that you can use to do that, to send it, is called UDP. I will explain. Let's just be going small. I don't want to rush so we can get it very well. If you want the delivery to be guaranteed, or you just throw it in bulk, or you just want it to get there anyhow, I've explained that. In IT, this is where you choose TCP, that is maybe transmission control protocol, to ensure really reliable and order delivery of data. That is, if you want a pure movement of data in IT, you use TCP. That's a secure way of transporting your data in IT. TCP. You use that using an application where accuracy is very. If you want the application when your own priority is accuracy, you use TCP. You know where you can use TCP. Example of this TCP where we use TCP is web browsing, where we use HTTP or HTTPS. In email is where you use what is it called now? SMTP or IMAP, POP. Let me just be putting it down so you can understand what I'm trying to talk about here. So if you want a guarantee, or let me just put it in a simple language, pure movement of data, we use TCP. E.g., all those web browser, HTTP transports, or HTTPS. So we use all this. Then that's for web browser like Chrome and other stuff. Then maybe if you want to, maybe in email, of course, we use SMTP. Then we use IMAP. Then we use POP theory. Then maybe in what is it called now? If you want to maybe file transfer, FTP, we use FTP for file transfer. Then that's just about that in transportation layer. Then the second one, and we explain all this thing, why TCP and UDP and this transport layer is very, very important. We explain. I just want you to understand this, the difference between these two first. Then the second one is UDP, which is this particular one, which is called User Datagram Protocol. This is very faster. This second one is very, very faster. Very, very faster, but less reliable. That's just the thing. Very faster, but less reliable. So, example of this one now. Let's, for example, let me tell you where you can use this particular UDP, where we normally use it. If you are doing live streaming, of course, we use UDP. That's the process of the delivery of it's being transported. That's UDP. For example, now on YouTube, if you are live streaming on YouTube, they use UDP of transportation. That's what we use. And for those that like online gaming, yes, online streaming, if you want to play game online, we use UDP. We use UDP for that. Video streaming, online gaming, then voice over IP, all those ones, we use UDP for that because it's not reliable. It's not reliable. You can attack it at any time. Unlike TCP that is very pure, reliable, this data is very, very secure. So that's the transport layer that I want you to understand. So now the next layer is network layer. Is the net layer. So now it's just like finding the address. That's why we started with IP address last week. I guess last week. So now you write your friend's home address on the envelope. I'm still using your friend and you. I'm still using them to explain this particular session. So now you write it, the home address on the envelope, so the post office know where to deliver the letter to. Of course, this is like IP address on the internet, like this IP on internet. It's just like that. The home address you wrote on your envelope, so that the delivery man will know where to deliver that particular letter you are sending to. Is also the same thing 90, the IP address that we talked about last week. It's like an IP address on the internet that helps your data to reach the location where it's going to. Example is like maybe number 2020 something, Lagos Street, or number 24, Lagos, or maybe Ojodu Street. It's just like that's what IP address, that's the network that we just seen last week. That's just about that. This one is very, very straightforward. Very, very straightforward. We just make use of IP here, IP address here. So the next thing now is data link. That's the next thing, data link. So this data link is like writing the postal code on that particular letter that you are sending. You also write your friend's house number and zip code so that the local post office where the letter is going to, of course, know exactly which house the letter will be delivered to. It's just like a zip code. That's just about data link that link them together. Writing the postal code so they will know where exactly where this letter is going to. So in computers, this is called MAC address. This is where MAC address is very valuable. That's the device address. That MAC address is what my computer will use to communicate with your own computer, not IP address. My MAC address and your own MAC address, that's what device use in online to communicate with one another. So I'm now saying that data link in your own computer in 90 is just like MAC address, your MAC address. That is, it helps when data move inside local areas like your Wi-Fi or office network. That's just about that data link, your MAC address that allow your own computer, 2 or 3 computers to communicate to one another. That's just about that. Then we have the last layer here is physical layer. Of course, this one is like a delivery boy. Let me just use delivery boy. Physical layer, or maybe the dispatch rider that you are using. You can see them physically. You can touch them. That this is the person that I want to go and deliver my letter. Of course, you know them. It's like using maybe the bicycle. You are using bicycle, truck, or mailman. Mailman, the person that will send the letter, that will send the mail, that normally deliver the mail. That's physical layer. That's physical layer. The person that will deliver the mail or the product or maybe item to your friend or to wherever it's going to. That's physical layer. Let me now relate it to IT. In IT, it's like the cable that you connect with this thing, the network. The socket, the cable, like internet cable that you connect to your socket, then to the back of your system, so that you can make use of network. In your own house, your HDMI that you connect to your computer, then to your monitor. That's the cable. Then Wi-Fi signal or fiber optics. Anything that physically move the OS, that move the data across the internet, that's physical layer. So that's just about this OSI model. So let's quickly talk about OS, operating system, small, before we call it a day. So we have OSI layer breakdown. As you can see here, mesh layer with reward example. This is reward example of layer 1, Ethernet cable, layer 2, MAC address, layer 3, IP4 routers, and as you can see everything here. So that's just about that. And IP4 working in OSI model. As you can see, we have everything here. IP packets are created and routed. So all this is what you can understand without talking more, wasting our time on all this particular area. So why it matters? Help understand how the internet functions. Crucial for cybersecurity, network troubleshooting, and system design. IP4 is key to identifying device. OSI model explain how data travels. Of course, that's what we just did. Layer approach makes network easier to understand. So that's just the end of this particular slide. So because I don't know that we're finish this one quick, but we still have little time. Real quick, we are going to I think I have it here. Okay, operating system. Good. Operating system is very, very, very important. You and I are here today because of operating system. What we are doing can never be possible if not because of operating system. All devices have their own operating system. Your phone, your iPhone, your computer, everything, all the device have their own operating system. So now, the core idea is, we already talked about other fundamental aspects. So now here is what is an operating system. So let me just, the way I normally break it down, let me break it down so we can understand. I know it's very simple. Most of us understand this, but it might not be to the extent of cybersecurity side. So now, imagine your computer let's just say our computer as a magic school. A magic school. Let's just say our computer like that. So this is what I'm talking about, magic school. Let's just see our computer like this. This is our computer. Let's say like that. So now, the operating system, in every school, we have either you have principal or headmaster. So now, the operating system, OS, is the principal or headmaster that tells all the students. Who are the students? The students are the app, the files, the hardware that you have on your computer. That's just about that. So technically, operating system, is the headmaster of that school. Then let's relate what I just said now to computer. So the OS, the everything, the computer, the file, the app, the hardware that we have on our computer is on OS. Can only work with OS. Let's, for example, if you go to market and buy a system, and the system have no operating system, there's no way you can't use to do anything. It's useless. If you format your phone, or maybe it's corrupt, your phone is corrupted, there's no way you can operate it. You can't see menu, you can't see your file, you can't see your picture. The phone will be virtually useless without operating system. So now, here, we have different type of operating system, like that is OS type. Example where we use them, as you can see from here. So now we have Windows, we have Linux, we have Mac OS, and we have mobile. These are the things that we target when we are working as an IT security or cyber security. This is what I can target. Nothing concerning anybody. Nothing apart from this. This is my target. So now Windows, we have Windows 10. Inside we have Windows 11. We have Windows 7, and so on. Then also we have Linux, in which we are going to use, do everything as we proceed with this training. Under Linux, we have Ubuntu, we have Kali, Paros, and others. So for hackers, of course, we use the major OS. Very one for hacking is Linux, Kali Linux, which is this particular one, as you can see. So, and we use the major operating system for, in this area, in this particular one, is Ubuntu. The major operating system for server. If you want to create a server, your own server, here is Ubuntu. So now I'm coming. Let me just open this thing. So I will not run anything, but I want to show you something. So this is my own virtual machine I have here. So this first one is my Kali. That's what I use for most of my hacking stuff. This is my Kali. Is Debian, of course. That's just the distro of Kali of Linux. So we have this one that I name as Legend is Windows virtual machine, and this second one also is Windows virtual machine. This particular one that I name Wasu server, of course, is Ubuntu. I use it for my own personal server, as you can see here. So I'm just showing you this. All this one that we have here is OS. All this one, as you can see, if I click on this, this is OS. You will see it very soon. It will be coming up. Then we have window here. This is my Kali machine, and this is my window virtual machine. We have everything here. So as you can see, this is my server. It's coming up. I shut it down because for the purpose of this thing. So as you can see, this is the server now. So that's what I just want to show you about OS, this particular one. So now I have this on my system. I have this particular one. I have this and I have this. Those things I just show you are just from this particular OS. The window is from this. The Ubuntu and the Kali is from this. Then this one also makes use of Ubuntu. All this Veteran and all this Sonoma, all this one. These are the Mac OS distro. Then the most important one that is very common that everyone should know, even though if most of us don't get our personal computer, of course, all of us, most of us have mobile phone. We have Android, iOS, and tablet and other stuff. So these are the common OS that we need. So why this one is important for us as an ethical worker is this. If you want to attack my system, you need to understand which computer, which OS I'm using. Once you know my OS, then you will know the kind of design that the kind of scripts that you are going to use to attack it. If you send the script that can break Windows system to Linux, it will not work. And the one that can break phone, if you send it to Linux or maybe this, it will not work. So you need to understand very well. And for some of us that is interested in IT support engineer, of course, these are very, very important. For example, if you're higher in your organization as an IT support engineer, your day-to-day task in every organization is to support users, to make sure that users are working perfectly and the tools are working perfectly across the organization. So now, if you are here for the organization that makes use of computer Windows system, of course, you need to configure the Windows system. If the OS is corrupt, you need to install or load another OS. It can either be Windows 10, it can be Windows 11, and so on. And for this Linux, if you hire a pen tester or maybe analyst, IT analyst or soft analyst, you need to configure, you need to install Linux or this on that person's system. So, and if with this thing is corrupted, you need to know how to do all these things. That's why this is very, very important. And that's why I call it fundamental that you need to understand. If we jump from, let's assume we did not touch this area now, we just jump to hacking and you know how to hack, you will just be limited in terms of knowledge. You will be limited because you will only have the knowledge of what we just introduced to you that you can use this to hack computer, to hack Windows system. If it's not working on another computer, you will now understand that you need to understand the difference between OS and how they work and how they function. That's why we need to. This area are very, very important. I know it's very simple for some people, but it's very, very important. So that's just about that. Also, we talk here about talks to hardware. What does OS does? As you can see here, talks to hardware, runs your app, manage file, and give a GUI. So now there is one thing I want us to. We already understand that one very well. We know that this OS talks to hardware, talks to file, and other stuff. We understand all this thing very well. And what happens when you press your power button? For example, immediately you put on your system, we have what is called BIOS and UEFI. We have what is called BIOS and UEFI. So all these BIOS and UEFI, they do a lot of things. They do a lot of things in our computer system. So now, let me just put it here, what I'm talking about, so you guys can understand what I'm talking about. Okay, before here, so we have what is called BIOS. This thing is very, very important. So let me tell you what this small thing does in every computer. So let's immediately you press power button on your computer. This is the major brain that do something. So it's a small program that that store is like a chip on your computer, on your motherboard, on your computer. So it wake up the computer. Immediately you press. When you press the button on your computer, the BIOS is the first program that that runs on your computer. What does it do? So what this thing normally do is that it check for the hardware. Let's, for example, you press your system, you will see your system that will be showing connecting or maybe searching or whatever. It will be showing something. Let's quickly check this. Okay, this one is up. Okay, this one is up as well. This one is up as well. So now, let me just key in my password. So you can. So now, as you can see now, it's running. It's welcoming us to this. So the BIOS is working. It's checking where the OS is located on your RAM, on your SSD rather. Maybe you are using SSD or you are using HDD. So the BIOS will check. Maybe there is a very correct OS inside that it can pick up so your system can run. So that's the work of BIOS and every other stuff. The BIOS. So it finds the operating system on your system and provide settings and every other thing to your system, so your system can build. So for those of you that are having boot problem on your booting problem on your system, just think of BIOS. If your system is behaving or blue screen, you are getting blue screen or it's not coming up, just think of BIOS system. Updating, if you have access to update your BIOS, of course, you will notice that your system will function perfectly and well. So that's just about what BIOS does. So now let's continue. We soon round everything up. I just want us to finish this small session. So now I know many people will be asking what concerns us about all this. It's very, very important to understand what is kernel here. Kernel is very, very important. It's very, very important as well that we need to understand. It's very, very important. So now, this kernel is just like is the brain, just like the way I put it here. It's the brain of every computer, everything. As I went to CMD, I key in some command and it brought out some information when we are trying to check for our IP addresses. This particular one, this one, other software that you are using on your computer, they cannot work without this kernel tools on your computer. You cannot see it, but it's on your computer. So as we write this one, IP, just wait, IP config here. So it's not this CMD that gave all this thing. This one is just like a GUI that just display all this answer. It's this kernel here, this particular one, that run this thing underground, like at the back end, that let us to see all these things. All the script that you have been writing on your computer, if you're a programmer, if you're anything at all, cybersecurity, everything, anything, engineer, this kernel is the one doing the work in your OS. This is what is doing the work in your OS. So it's the core of the OS. It helps the hardware, like that is your CPU, your RAM, your storage to talk to software or app on your computer. This is the kernel. This is what is doing the major work. That bridge between the hardware and software, manage resources, handle system calls, runs in kernel mode, and secure and power. Everything that you are doing is this particular kernel that is working behind the scene, doing the whole thing. Anything you are doing, the result you are getting is this one that is doing it behind the scene, that is doing the whole work, a lot of work. So now here, this is just the type of kernel. So we don't need. I just want you to know the type that we have. So this monolithic is for the Linux computer, while this micro kernel is for the Linux or this Apple computer. Then this hybrid kernel is for Windows system. So I just want you to know this one. It might not be important, but just for you to know the type. So now, the next thing now that we are going to check here, we soon end everything, is this file system. File system is very, very important. File system is very, very important, especially when we are talking about server and other stuff. So this file system, on Windows, we have Windows uses NTFS. I will explain. Linux use E extension, like extended. We have 4, we have 3, we have 2. But this is the latest one. Extended 4 is in the 4th extended is the latest one. Then macOS uses APFS. So we need to understand those things. I will explain everything so you can understand what all these things stand for. So now, like I said, let me start from Windows. I said Windows uses NTFS. It's very simple. If I'm too fast, if I'm rushing, please just let me know. If you have any question, stop me, let me know, so we can talk about everything, because I want you guys to understand. And I'm rushing because this one is the fundamental part of it that we need to understand. So, and I see it as something direct, straightforward. That's why. So now, like I say Windows use NTFS, which is a new technology file system. New technologies file system. So that's what Windows use. If you want to transfer and everything for the file. Then this one, Linux uses this. So let me just quickly explain this one. This by Windows phone. So Windows system, we have before, we have XP, we have Windows 7, we have Windows 10, we have Windows 11, and other, or etc. So it's the default file system for most Windows computer. This is the default. You can create your own, you can use another one, but this is the one that Windows uses. This is the one that Windows uses. This particular one. Then this one supports for file permission and security. We use this one for file permission and security for large file. If you want to transfer file, example for maybe a file over 4 gig, we use this particular NTFS to do that. Then maybe these quotas and other stuff, journaling, that is, you want to recover maybe your system crashes and you want to recover your file and other stuff. Of course, Windows uses this particular one, new technology file system, to do all those things. Then we also talk about this particular one, which is Linux. This Linux one is first, we call it EST4, that is First Extended File System. This particular one, of course, is just like a Windows system. So this has the successor is we have 43, third extended, we have second extended, and and so on. But this is the latest one, which is First Extended File System. That's what Linux use. Most Linux distribution like Ubuntu, Kali, Debian, etc. Supports large volume, like up to 1 exabyte. It's not terabyte now, exabyte. File transfer. So now this is now telling you this is exabyte. I mean exabyte like this. I think it's ESB BYTE. This exabyte. One is support can transfer large volume of data. Exabyte. Just check the volume of this. That's why this one is used for supercomputer. If the OS being used in supercomputer is Linux OS, because we can't use just this window to power supercomputer. We can't use this one. We use Linux for that. So now we also have, it's very fast, very, very fast. This particular Linux, very, very fast. Then for journaling, I said journaling is for maybe you, just like NTFS. The journaling, what we use journaling for is to recover maybe file system, maybe your system crash. In a system, there's what is called journaling. So if you search your system, you will see all these things. So to recover your data, maybe your crashes and everything, we use it support that. That one support that. Then we have backwards compatible with SSD and every other stuff. Then the last one here is macOS uses APFS. That's the file system that this macOS uses. So now this one is very unique. That's why most people like MacBook, to buy MacBook or Apple phone, just because of this. Because it's a special way that Apple computer like MacBooks, iPhone save and organize files. If you see the way MacBook organize their own files, even from other system, very, very different. It's like a smart. Just see this as a smart bookshelf where you arrange your photo, your video, and everything. That's just about that. So, and Apple started using this. I think it's using it because it's very fast. It's more secure, faster and better, especially when your system is using SSD as a storage. So that's just about this that I want you guys to have the knowledge about. You don't need to cram anything, but you just need to have it at the back of your mind that, okay, the file system that Windows is using is NTFS. The file system that Linux is using is First Extended. The file system that MacBooks is using is APFS, just for you to know. Just for you to know, in case of if you want to do anything at all. So I want us to know about the process and the thread. Process and thread. This is very simple, and you will see why I say it's very simple, and that's why I put Chrome here. So a process is a program that is running, e.g. Chrome. So now, and a thread is a smaller task inside the process, e.g. loading a tab. So now, let me open my Chrome so you can see what I'm talking about here. So this is the Chrome that I opened that time. So now, if I open this one now, here, this Chrome that I open now is already running. How do you know that this is running? On your computer, just search for Task Manager. Search for Task Manager. I'm opening mine so you guys can see. So this is my Task Manager. This is my own Task Manager here. These are the things that is running on my system at the moment. These are the things that is running. So also, if I'm managing server, you'll be having this one too. If your server is very low, you don't need to ask if people are complaining, if your server is very, very slow. All you just need to do, go to your server, then open your Task Manager, and you will see the running process. As you can see now, at the moment, my memory is 93%. Why? It's very high. I can know. You will know from here which one is assuming much more memory than the other. As you can see now, these teams is taking much, like almost 1 MB, as you can see, and this one is taking like this. So these are the things. So if I want to reduce this one now from 93% to maybe lower percentage, of course I can close some of this one. Like this one, I don't automatically, I think it's opening itself. I don't make use of it, so I can close it, and you see it's reducing small, as you can see here. So this one I'm using is, if I have one that I'm not using, this one is automate. It's working anyway, but I'm not using this power automate, though it's working at the moment. Then this sandbox as well, I'm not using it, but it's working as well. So this one I'm not using at this moment. I can end this task. So if your system is very slow, this is what you can do. Just come here, look at this application, that the one that is running, the one you are not using, you can close them, and you will notice my CPU is very in a good state. You see 9% out of 100%, so it's still very good. This one, despite the fact that my system is 32 gigabytes, is showing 91%, which that is a lot of program, a lot of things are running. So now I want to show you what is process and what is thread. So this is the process now. As you can see, everything that you can see here are process. As you can see at the top, as you can see here is a process here. This is the process. So everything here is process. So now, but under process, we have sub tab. Let's, for example, now I open this one. Inside here, I open another tab. I click on maybe Archive News. I want to read news here. Then I open another one. I do this. All these ones that I open down are called thread. That is, in Oxshare, a thread is a sub tab inside the process. So now let's go back to our task manager. So from our task manager, of course, we get to discover that here, that inside here we have 18. So this is 18 now here. This is 18. Therefore, in Chrome now, we have one process, which is this Chrome, but 18 thread, as you can see inside. In Teams, on Teams, we have one process and 10 thread, as you can see here. That is, maybe I'm doing 10 tasks, 10 tabs. I open 10 tabs down at the same time. That's it. So you'll be seeing the number of threads. You will always be seeing side brackets here. So that's the difference between thread and process that we need to understand. So if your system is very slow and is loading, why most of our system is very slow and always struggle to load is because there are some startup application here, this particular place, that you can stop. As you can see now, I enable some and I stop some. So if you stop some of these applications that you are not using, I'm telling you that your system will be very fast when loading or coming up. So that's just about that. And we have a lot of things here that you can check as well, because I'm showing you all this. I want you to understand the basic, the fundamental part of OS and everything. That's why I'm showing you this powerful area in your computer. You might not know the uses now until when your system is 40 or when you are trying to hack a system. I'm talking about hacking for educational purpose, not for any other evil thing. So now you get to understand this. There's a lot of things that you can check here. You can check everything here, the users. You can check the services. These services that is running here, you can check. You need to know them, what these one are doing here. So if you're on the server, you can make use of all these things. You can enable some and you disable some. And if you are doing something that you don't want it to go internet, but you want it to be connected to internet, but you don't want it to be accessible to internet, of course, we talk about sandbox. So sandbox is also on your computer. It's just that you might not know where you can find it on your computer. So sandbox is a confined environment where you can carry out everything, but nobody will not be exposed to internet. So that's just about that. And if you want to activate your sandbox, all you just need to do is to search for control panel on your computer. Just search for control panel. So if you search for your control panel, I'm coming, let me quickly show you. I'm very sorry that I'm taking much of your time, but you need to understand all these things. So you search for control panel. From your control panel, of course, you go to system. I'm coming, so let me just search for it. You go to program. You go to program. From program here, of course, you navigate to turn on window feature on or off. On or off. You click on this particular area. So when you click on that particular area, of course, it's open in my own major screen. Of course, you will see a lot of things here that you can use. That is very, very important. And if your virtual machine is not working, maybe you want to make use of hypervisor or every other things on your system or machine platform, everything. Of course, what you just need to do, all these ones that you see me that I mark, is because I'm using them. So let's assume that you want to use Sandbox on your system. Of course, Sandbox is here. All this, you just come here, TFSTP, tenants, because all these things you might want to go further, advanced one, so you will know where to get all these things. That's why I'm showing you this environment. If I want my Sandbox to be working now, this is it. I will just click on this, then I just if I click on this one now, I'll be able to I enable it now. So my Sandbox will be, if I restart my system, everything will be working perfectly. And if you want Windows subsystem for Linux, you put this one on. Everything other, you can come here and check a lot of things. Hypervisor, maybe you want to be using hypervisor on your system, you come here and enable it. So that's part of your OS system that you need to understand. And I believe most of us can install and uninstall. For example, I'm showing you this place as well. Let's example, you gain access to my system and you want to know the type of application or software that we are using in the organization that I'm using this PC for. Of course, you just come to this control panel. Then from the control panel, you click on uninstall a program. From uninstall a program, you will see the number of software that I'm using. You can now check that which one can I attack, which one can I use, which one can I check. As you can see, I have all this thing on my system. So it's you that will now check which one is I can check so it's you that know what you want to do. So that's why I'm showing you all this particular place. And this program and features. This under program and features, of course, your system do automatically update itself. For example, some people are getting blue screen. It will just be, maybe you are trying to do, you might be working and you just get a blue screen that your system runs to maybe error or whatever or problem. Of course, it happened because maybe there's an update that is not compatible with your system. So because of that, your system will be misbehaving. So if you want to uninstall that particular features, you just come to this view install update. You click here. Of course, from here, you'll be able to check and see which update is not compatible with your system and the one that is compatible with your system. So that's just about these particular features that I want you guys to understand. So now I think we are about to finish to round up everything here. So now here, last thing I said, what is OS security? So OS security means protecting your computer from bad guys and stopping mistakes that can break things. So this OS security, maybe next time when we talk about much about this, what are we protecting? What are we securing? And why is it important we talk about this? Also, this is what we need to do when you are building an application or you are configuring a system or you want to build a solution or architecture about, let's assume that you're a cybersecurity architecture. So your own role is to be able to develop a software or an app that will be able to defend your organization from bad guys. Who are the bad guys? The black hackers. So they are the bad guys. So now see, you make sure that the software, that the solution you are building will be able to log in, secure login, then must need permission. Anybody cannot just sign in. Process control, you must be able to control process. It's not that maybe you will, for example, you build a solution, maybe let's assume that you build an app, a transactional app. So anybody can just go in and make a transaction. That's not a secure solution. So you must make sure that you process control, then execution and alert and logs. So this execution we are going to talk about, but not today. So now we are done with this. Then the last slide here before question is, what do we want to protect? What we are protecting? What are we protecting in any organization you find yourself? The main reason why we are doing this is for us, if you want to work, because all these things that we are talking, if they want to interview you today now, if you call yourself maybe a SOC analyst, or you call yourself an analytical hacker, or they will ask you all these questions, all these things that we have been talking about. What are you protecting? In exam, maybe you want to fill any certification exam, you will see all these things there. That's why I just I want you to understand the fundamental part, so you will not be like practical alone. That's it. So now this particular file, you are protecting file. You are processing account, you are processing program, then internet connection, the whole system. That's what we are protecting. A secure system is just a better organization. So that's the end of what I have for you today.